Right, good morning, grade 11s. Sorry I didn't have a lesson yesterday. I was busy making a video for the talent show. It actually took me a while to finish it yesterday. Um, yeah, I hope you get a chance to see it. Some of you were in the video, so I'm going to leave that as a little surprise for you, but I thought I'd tell you that. I know I mentioned it in the group chat, but maybe some of you don't follow that. So, all right, so look, I'm going to explain to you how motors and generators work today, and something called the motor principle. I'll get to the motor principle in the next video. Okay, motor principle is very straightforward, but how motors work. Okay, so in this video, basically a motor, an electric motor for context today, is a device that you plug it in and it spins. So there's lots of examples of electric motors in our lives. Like for example, if you have a fan at home, like whether it's a ceiling fan or a bedroom fan or this a fan sits on the table, spins, right? You plug it in, it spins. My electric car, okay, we have a van and a Tesla or whatever. They both have electric motors in them, and you apply electricity from batteries in this case, and then the wheel turns. Okay, so that's what powers the car, makes it go. So electric motors are definitely an area of very much like increased development, research and development these days on how to make efficient electric motors. It's very different from the way internal combustion engines work by turning a shaft, which then turns an axle and spins the wheel. It's not exactly the same that way. So in this case, the way it works with electricity is a very different thing. But basically all motors consist of the same basic parts. I don't mean gas ones, I mean electric ones. So we're going to look at that today. What I'm showing you here in Microsoft Word, and I can't show you this in OneNote, not exactly like this, because OneNote it doesn't allow me to rotate the motor. Okay, Word allows me to rotate it. But here I have, this is a DC motor, okay, and you need to see, I'm making a video like this, not just a note, because you need to see it in action, okay. Motors, when you're not seeing them in action, you can't really appreciate how they work, okay. Now what I'm going to do is I'm going to label these two. This red bar that I've scribbled in is connected to the positive of a battery, okay, and the black bar at the bottom is connected to a negative, okay, so if that makes sense to you. So it's positive and negative, okay. Also, what is on the perimeter, and what I forgot to include, there's a magnet. So I'm going to draw a little bar magnet here, make that one north, and then this one is south. Sometimes they have U-shaped magnets. So anyway, there's my magnet. Now you need magnets, okay, to have a motor, and you need to have a number of things. So this is basically all you need. You need a power source, like a battery. You need your red and black brush, although of course they're not colored, they're just a brush that brushes against the spinning system of the motor. You need to brush against it because when it spins, you don't want the wires to get all twisted up, right? So it brushes against something. There's a split ring that's colored brown in here, okay? That's on this rotating armature, okay? So there's a split ring on this gray rotating cylinder in the middle. And then there's this blue armature on this side and a red armature on the other side. The colors are irrelevant, but the blue is, there's a coil wrapped around it, and that coil continues, and it actually is the part of the same coil that's wrapped around. You just don't see all the windings, but you know, it's wrapped in there somehow. These coils are connected, okay? And then they also touch against the split ring, which in turn touches the brushes, okay? Now, what I'm going to do, and I hope this works, I'm going to zoom in on this picture, and current flows from, I'm going to use a different color, I'm going to use blue, okay? Current will flow this way, or it's rainbow color, I guess, so whatever it is. It comes in from red, it's conventional current, right? It's going to flow that way through this metallic ring, and then it's going to enter my coil right here, and it's going to flow that way, and then it's going to go around the back, flow down this way and down that way, and then it's going to actually go behind my my motor here, come out the other side, and do the same thing here. Whoops. And then it's going to go like this, and it's going to exit, okay, through the black brush and go back to the power supply. Okay. Now, it's really important that the motor is able to do all that. Okay, like you need to get, the power has to go in and come out. It cannot be stopped anywhere inside the motor, right? So there's just basically a coil wrapped around an armature, and the deal is that this armature is free to rotate. Okay, now I'm going to use my right hand rule for solenoids. Okay, my fingers of my right hand wrap around the front of the coil, okay, which come down the front face. My thumb will point towards north, so that would make this a north pole and that a south pole. Okay, so here we're going to get repulsion. North repels north, right? And here we also get repulsion. So the magnetic field of my electromagnet, okay, the red and blue arms are like an electromagnet, they actually are repelling from the permanent magnet that is located outside the motor. Okay, now I'm going to erase these lines that I made. Okay, I'm going to erase everything because they're not going to rotate, so I'm going to actually just erase some of the lines that I made here. Okay, like that. I'm going to erase that one too. Okay, so now, since they repel, my motor, I know my motor is going to spin, and it's going to spin counterclockwise like this. Okay, so it's going to spin around. Now look, if you look at what's happening, it's a bit hard because they're showing a ghosted image of the fixed one. The brush at the top is still touching the same half of the split ring. So now that red one is still north and the blue one is still a south, right? So the red bar is north, the blue bar is south. The north one is attracted to the south, and it's going to rotate till it gets to here. And then at this point, something has to change, okay? So look what's happening now. This is still a north, that's still a south, and so it's going to continue to rotate counterclockwise, okay? But then it would normally stop rotating now, because now that it's sort of reached, it's a point of attraction to these this external magnet, but something's about to change. If you look, the red brush is approaching a gap in the split ring, and same with the black brush down here. And in just a moment, they're actually going to pass over the gap, and then the red brush will be touching the other split ring, and the black brush, same thing. But that's actually the whole point. It's really important. Okay, so if you watch, we keep going. Now the red brush is passing over the gap, and then here in this position, they have now switched which half of the split ring that they're touching, right? And so now what's happening, if I trace the current like I did before, the current is going down here like this now on the blue side. Okay, it comes down here like this as before, exits this way, okay, and it goes out that way. But if I take my right hand rule, now this side is north. That used to be, the blue one used to be a south, okay, and the red one used to be a north, but they've switched. Okay, now they've switched polarities. So what happens is our electromagnet has switched which pole is north and which pole is south. Okay, but that's really important, because what's a motor supposed to do? Well, it's supposed to keep spinning all the time. It's never supposed to stop. Like if I plugged in my fan and it only spun a half turn and then stopped, that's a useless fan. Like you want it to keep spinning, right? And so it's designed specifically to do this. That split ring that you see in the middle helps it to keep spinning, because now the brushes have switched contact with which side of the split ring that they're touching. And now they repel again. These repel and these repel. Okay? So they did attract at one time, as the red one was attracted to the south one when it was a north pole. But just as it gets there, it switches and it changes from a north to a south, and that keeps it spinning. So it's a very clever design. Okay? So watch, this will rotate around. The blue one is a north, right? It'll rotate around, and then here Okay, oh, I should have erased these things. Okay, so here, what's happening is the blue one is a north, but look what's happening to our brushes. It's about to switch. Okay, in other words, they're about to cross over the gap. Okay, and here, as they cross over the gap, in this position, now they switch poles again. Okay, and we're back where we started from. So every half turn, this motor is designed to flip the polarities, okay, of the rotating armature to keep it spinning, in this case in the counterclockwise direction. Okay, now if I were to make some kind of change to this, let's say I were to make a change. Let's say I change this one to, it was a north, let's say I make it a south, and I make that one a north. They have to be opposite poles, okay? Well, what's going to happen now? Well, if I trace the electricity through my system, it's going to go that way, like as before. This will still be a north, okay? It's going to come in this way like that, exit that way, so that is a south. But now, instead of being repelled, now they attract, okay? And they attract on that side too. So which way is it going to spin this time? Well, it's going to spin this way, okay? And in fact, it'll keep spinning. Like once it crosses here, these poles will reverse. Okay, again, as soon as they cross the gap. So watch, if I trace it now the electricity is coming out this way. It's going up here like that. Okay, coming back down here like this, exiting this way. Okay. And then what happens is, if I use my right-hand rule, now this has become a north, that has become a south, and they're going to repel. So they're going to keep, it's going to keep spinning in the clockwise direction. So just by switching my external magnet, I can make it spin the other way. Okay. Now most motors that, like if I have an electric drill, let's say, it has a switch on it that allows me to switch where the plus and minus are attached, okay, to my rotating armature, and that will reverse the direction. But yeah, that's how you reverse the direction. Okay, and this is everything you need to make a motor work. Okay, so that's it for this demonstration, guys. The demonstration is very important. Like, I hope you got to watch this video to get how the motor works. Okay, so with that in mind, I'm gonna now give you some notes, okay, on how this works, and we'll take it from there.